So this is our last lesson for Unit 5. Tomorrow is going to be a review day. Thursday will be our test. I'm not going to do a review test or an FRQ for this chapter. So we're just going to have a test on Thursday, and then on Friday we're going to move on to Unit 6, okay?
Wild.
Wait, what?
Oh yeah, you didn't even know about that.
Just because I think we need to move on. And
Billy,
not,
do you want me to get descriptive about the Rajai section?
no, because I just started recording, so I'm actually going to. So, guys, might want to be quiet, please.
Bye.
All right, so here we go. We're going to be doing inverses of cube and square root functions today, and we're also going to get into graphing them a little bit. Okay, so that's the goal. So you don't need to write this, but just as a quick rehash, how do you find the inverse of a function, and what is the inverse? Well, an inverse is where the x values and y values are swapped. Okay, so that's how you do it. Really, you start by switching the x and y, and after that you get the y by itself. Since domain and range are just the x and y values of each function, when you have a function with these domains and ranges, the inverse of that function will have the same domain and range, but they're switched. So like, for instance, the domain of this one is a to b, Demir, and then the range on this one is a to b. Whereas over here, the range is c to d, and the domain is c to d. Demir, go sit behind this guy. I'm going to start splitting you talkers up whenever I'm teaching. There's too many people in here talking. So Demir, I'm going to have you sit behind Gene, okay? All right. Now, you guys are going to need to make a correction on the notes that I handed out to you. First of all, I got the letters wrong on this side. Yep. And this is supposed to be a Y, not an X. So make sure you guys correct this. No, it's on the handout I gave you. You just need to make the correction. All right. So we're going to find the inverse of cubic functions and square root functions. Let's do that. So the first step that we're going to do, guys, is you always start by switching the x and the y around. That's too far. Don't need to go that far. Oh, this is supposed to be a y now, right? Okay. Now, the next thing after you have to switch the x and the y is you want to get that y by itself. So the first thing I would do here is I would minus the 2 on both sides. And that would give me the following. Oh, I didn't give you guys a chance to write the problem, did I? I'm a bad person. I'll wait. All right, guys. What do I do now?
Huh?
He needs a tape. Divide by 2?
Wait, the what? Wait, oh, I was like, oh, wait, sorry. What you said? Sorry.
You were just like, no, how would you like?
Divided by negative. Oh, what? That's cool. Oh. I keep forgetting you don't.
No.
Okay, what's next?
Wait. I'm trying to figure out what you.
No.
Multiply by 2?
Okay.
Is it multiply?
All right. So what we want to do is we want to get rid of this cubed root. The way we're going to do that is we're going to cube both sides. The cube cancels out the cube root. And so now I'm left with the following. I have x minus 2 over 2, and that's cubed, is equal to 4y minus 3. We're getting there. And at this point, I would assume you guys probably wouldn't have too much trouble. But notice what I did first was I got rid of the numbers on the outside first. After that, I cubed both sides. And then from there, we just kind of used some basic algebra to bring it home. So in this case, I'm going to add 3 on both sides. Then we're going to divide by 4. Well, I find that if I don't go fast enough in here, you guys get really distracted and then I lose you. So that's why I'm burning butt here, keeping you guys on your toes. But if you guys can actually be quiet, I'll be able to slow down a little bit.
I'm sorry, Bailey, that's not possible.
Where did the 4 go? Yeah, where'd the 4 go?
Yeah, where did the
Divided
four
it
go?
out.
Where did the 4 go? The 4 disappeared because Austin was interrupting me.
What are you talking about?
What the heck is that thing?
And you don't want to do a review?
Mr. Bailey, you're scaring me.
I don't want to review that. Me personally.
Who needs a review test?
Do you see why I can't stop? Like we have like a cacophony going on here, so I gotta get burned. Otherwise, you guys start talking and doing.
But we're
All
talking
right.
about
So we're
what
talking
that
about
thing is.
assignments.
Yeah, but I mean, when you have a problem in math, you raise your hand, you ask a question, and I answer it. We don't have a huge class discussion for 20 minutes about review tests.
I'm listening to the Precal.
Exactly.
There it is. So we have the whole class talking now. You see? All right. So quiet. All right. Still talking.
We're definitely talking about how that is.
Well, all I did was some basic algebra, so God bless you if you don't get it. But now I'm going to show you something else here. So, you're still talking? You guys talk too much. Let me teach. All right. So, here we go. This is a perfect answer. I'll leave it. But all I did was some basic algebra. Add the number, divide. That's how you get y by itself. That's old stuff. That's since 8th grade. If you don't get it, the Lord be with you. But we're going to go ahead and talk about someone who might want to go a little bit further. I'm going to show you guys how you can simplify this a little bit to make it look prettier. Because this is a cubic function. And the way a cubic function should look is kind of like this. Kind of like every other function that we do, right? So it doesn't quite look right. I'm going to show you guys some ways you can massage this to make it look prettier.
Wait, so like how we massage the rat in anatomy?
Thank you, John. All right. So instead of putting this thing with a 4 underneath of it, I'm going to write it like this.
4 on the top.
What I did was I put a 4 in the front of this, like a 1/4, and then here I put it as 3/4 over there. So that looks a little bit better, right? But the inside still looks a little funky. Okay? So I want like a bx minus h. Well, we could do the same thing I just did there. I could put a half in front of the x, and then 2/2 is 1. Now, I will give you guys full credit for this answer.
Isn't that just
But that's really ugly looking, and so if you want to learn how to make it look prettier and more normal, that's what it should look like. Yeah? No, I won't say it all again. But I don't know, guys. It's because the class is really distracting. We talk, and so like I don't think I should have to go over it again. But if you have a specific I won't do the whole thing, but I will definitely answer a specific question. You got a specific question for me?
How did you get to top?
What do you mean? This? This?
No. Yeah, I did get that.
How to get this?
Yeah.
Okay, so this whole thing is being divided by 4. So that's like the same thing as multiplying by a 4th. Don't you agree? Okay, so instead of putting this over 4, I put a 1/4 in the front. And here I just put 3/4. Okay? Yeah, that's it. I just made it look prettier. But like I said, you guys don't have to do this. I will give you guys full credit for this. But this just looks a lot prettier. Even that's kind of ugly, but yeah? I would take either one. So on the multiple choice question, I don't think there's a multiple choice question for these. It will be a free response, so I would take either one.
We definitely need to review.
Thank you for your input. Any other questions about that one? Yeah. This guy? Same thing that it was kind of like what his question was. So first of all, I thought of x minus 2/2. I'm thinking of that as x/2 minus 2/2. And then that's 1/2 x, right, minus 1. Any other questions about the algebra there? But like I said, that you guys are getting stuck from here to here. And like I said, you don't have to do that. You could actually just leave it. Okay? And a matter of fact, the one I'm going to give you is a lot easier. I just kind of gave you a worst case scenario here. You guys ready?
Yes.
Yeah. Student practice time. Let's do it. There you go.
Why would you say that?
All right. So Escobar. I'm gonna. Okay. Go ahead, Cece. What do I do first?
First one is, no, so you take out the X and the Y. No, switch them.
You switch the X's and Y's. That's right.
You don't want to put them in right now, but I'll go through the whole problem.
Okay. Escobar. What's next?
Oh, plus one.
Did you give the answer, or are you asking something else?
No.
Okay. I'll come to you if Escobar
Like
fails
add
it.
one on both sides.
Okay. So we add one on both sides. All right, and then why don't you go ahead and tell me then, Hassan?
Cube both sides.
That's right. So here we're going to cube both sides. So if I cube the left side, I get this. If I cube the right side, I'm left with this. Now, some of you guys are really tempted to try to be cubing this. There's some wrong ways to do that. Like I saw someone out there today do 3x plus 3. That would be like 3 times this, but it's not 3 times this. It's this to the third power. So you can't do that. The other wrong answer I saw earlier today was x to the third plus 1 to the third, but that's not how it works either. It'd actually be x plus 1 times x plus 1 times x plus 1, which you'd have to do a lot of FOILing and multiplication. The good news is you don't have to do that, so we're not going to do it. Just leave it like that. But let me come to Alan. What would we do next, Alan? Okay. Want to take a guess? Okay. Go ahead, Austin. On my example, we did. On this one, that's not necessary because on my example, I had a number here. Ishmael? That's right. So we're going to add 5 to both sides. Because remember, let's not lose sight of our goal. I know that on my example, I had different stuff. But here, our goal is just to get y by itself. And we can see all you have to do to get y by itself is add the 5. So there's that. Now, I'm thinking about making an extra credit lesson. I'm not sure if I'll get time or not. But we're not going to graph these ones. But I'll give you a little sneak preview. Okay? So you do not need to write this down, but you're welcome to. I'll go into more detail on this on the extra credit lesson. But I'm gonna ask you guys some questions here. So I want to graph this really quick, Diana. What's the starting point? Yep. 5, negative 1. And this is a cubic function where the a and the b are positive. So it should be starting low and rising and then doing that. Right?
Correct.
Now this, we haven't learned this yet. I doubt you've talked about it in Algebra 2 yet. But when you have an x to a third power, that's what's known as a cubic function. Cubic functions look like this. Okay? Now, if they have negatives on them and stuff, they can be reflected too and stuff, and that would be the extra credit video if I get around to it. But I don't think we really need to worry about it here. So let me ask you this. Montgomery's not with us today. Let's see. Demir, what's my starting point on this one? Negative 1, positive 5. So negative 1 at 5. And then I'm just going to put that shape there. It's like a taste of it. We'll go a little deeper on the video, but yeah, it's like that. Now, this is correct. You want to know how I know? We learned something about inverses a couple of weeks back, and that is that they look like a reflection through this line. You remember that?
Oh yeah.
So I'm going to go into a little bit more detail about these and other inverse stuff, but that's just a heads up. You don't need to do that right now. However, we are going to do that right now for square root functions because there's something that's kind of important we're talking about there. So let's move on to example 2. Did I print this one for you?
Yeah.
All right. Here we go. So let's graph the function. You guys ready? Yes, Mr. Bailey. Awesome. Hassan,
Bailey, stop talking to yourself.
what is... I'm not. That was you guys. Hassan, what's the starting point?
2.
Uh,
Oh, wait.
is the one that I printed different? Maybe I printed for you guys in student practice. Huh?
No, you think they're all
That was the same one.
Unless the student
We
practice.
just don't have the graph.
No, mine's different.
Because the graph is on super.
It's on the top right, guys.
Oh,
Top right.
There's no
Oh,
graph.
it's negative
There's no graph.
-1, -3. So let's all put a dot there. And I'm going to ask Kevin to access his powerful memory. Kevin, which shape is it? Or Oops. What do you think, Kev? Which of these is it? Top left is correct. It's We know it's because we have a positive here and a positive here.
Right.
That means going up. That means going right. So That's from yesterday. So if you weren't here yesterday, that might feel a little weird. But there it is. Okay. So we've taken care of part A. Just a review question. Let's do the domain and range.
Oh, I thought you said you
You guys ready? All right. Domain is all the possible values of x. So what x value is furthest to the left?
-1.
Good. Now can my graph actually equal -1?
Yes.
Yes, let me put a line there. How far to the right does my graph go though? Infinity. All right, let's do the y values. So what's the lowest y value on this graph? -3, and it equals that, right? And then it goes up forever after that. Okay. Now we get to find the inverse, part C. I want you guys walk me through that too a little bit. Ah, you got it. I know you got it.
Isn't it the opposite way?
Let's see. Can you guys remind me what was the equation? Is y equals the square root of what? Like that?
Yeah.
Okay, so I want to find the inverse of this function. So Talia, what do I do first? Very good. Somebody was paying attention. All right, next part. Tristan, ¿qué más? Can't see? All right. How's about Smith? Halen Smith. Now what? No.
Good job,
Go ahead, Ishmael.
Austin.
I had a lot of hands there. I was confused, but go ahead, Ishmael. Yeah.
Good job, Austin.
So we're trying to get y by itself, right? So the first thing you want to do is add the 3. Hungry for knowledge. Dylan Lee Bryant.
Who's Dylan Lee Bryant?
What's next?
How to say it.
So we want to get rid of the square root, right? Which is a second root. So what we do to get rid of the second root is we raise it to the second power, which, yes, you could say squaring it, right? All right. That leaves me with y plus 1. All right, now I'm going to be coming at Sophia. What do you think, Soph? Yep. We're going to minus the 1. And we have this. So there's our inverse.
I feel like the square ones are.
Okay, let me ask you guys a question. What kind of a function is this? What do we call this?
Square.
Right there.
Radical. Function. What?
That's a square root function. Now, what do we call this? Raise your hand if I get you extra points. Yes. No, it's a good guess. I'll give you a point for that. But I'll give 2 points if somebody can tell me the correct answer. King? No.
That's N.
That's all right. Go ahead.
That's all right.
It's a quadratic equation.
I said that! Mr. Bailey!
Sorry.
Everyone heard me right? Okay. Alright, you know what?
All right. So I want you guys to repeat after me. You ready? The inverse of a square root function is a quadratic function.
I never knew that, Bailey.
Okay. So now that we know that, let's write down the answer. So what was that? That was x what? Final answer was what? X?
X equals 3.
How is X when it's Y? Oh, wait.
X plus 3.
Yes.
Minus
Plus,
1
minus
equals Y.
1.
That's it? Okay, thank you. All right, now we're going to do the domain and the range. So all of this is old news. We've done all this stuff before. Let's do the domain and range though. Now since this is the inverse of this, we kind of can cheat a little bit.
Not really. Yeah.
What would the domain of this function be?
Maybe negative 1. Oh, negative 3.
Negative 3 to
Infinity.
y.
Because
It's stuff.
That's right. The domain of this function has to be the range of its inverse.
Oh, snap.
It sure does. Just don't forget to make sure you put a y there. So it's going to be the same numbers, negative 1 and infinity, but with a y in the middle. Okay. Now, let's graph it. Now, this is a review question. We haven't done this in a couple of weeks, okay? How the heck do you graph this function here? I'm going to review with you.
it's a parabola.
It sure is. Nice job. Okay, so my first question is going to go to Ishmael again. Ishmael, what's my starting point? Good. Now, bonus point, raise your hand if you're interested. What do we call the starting point on a quadratic equation? I haven't gone to Dylan yet. It's called the vertex.
I was going to be right anyway. Dang it! You got to be confident.
Okay, now, I'm going to ask Taekwon. Taekwon, is this a happy face parabola or a sad face parabola?
Sad face.
How do you know it's a sad face? I like your answer halfway.
You're both negative.
So here's the thing. You're right. If it's negative, it's a sad face. But here's the key question. If what's negative? The number in the front. So now let me ask you again. Happy face or sad face? Happy face, because that one's positive, right? So since this is a positive A, we have a happy face. So let's graph it. Ready? Left 3, down 1. Left 3, down 1. Now I don't want you guys to draw this. Don't draw it yet, okay? Because I'm going to do something that you might not be able to undo. Ready? But I'm going to draw a happy face. Now let me ask you this. Does this look like the inverse of that?
No.
Not quite. Something's wrong.
It's missing another part.
This guy is only half of it, right? There should be more.
Alright, where is it?
So here's the thing. I want to know what's the inverse of this, right?
Oh,
Which half of the parabola is the inverse of this?
The left half.
right.
The left half is the inverse?
Yes.
So that means I should ignore this.
Yes.
Does that look like an inverse?
Yeah.
So I was the
What half is the inverse? The right half is the inverse. So I'm going to erase this. Does that look like an inverse? How do you know if it's an inverse? It should look like a reflection through that dotted line. Remember that? So in this case, it's the right half. Will it always be the right half? No, it depends on what this looks like over here. Okay, but there it is. Now here's another way you can tell. Look at what we wrote down over here. The domain goes from -3 to infinity. So x goes from -3 to infinity. -3 to infinity. If you did the left half, that would be from -infinity to -3. Okay, so you got it. So this can kind of help you know which half to pick, but I think it's easier just to tell by looking at it which half to put. Okay, so since I want the inverse of this function, we're only going to do half of the parabola. All right, that's kind of a weird little detail. All right, let's do another one, but this one's going to be like a guided practice. You guys are going to do most of the work. All right, so go ahead and graph it. I'll give you a few seconds. We need to do this. And then I'm going to take what Caitlin said, because I don't like that negative in front of the x. So now I'm going to take that -1 out. Now you guys can graph it. By the way, I'm missing my k. What is it?
0.
Okay, now go. Very good. So we all should have put a dot right here.
Yes, okay.
Next, I'm going to ask Isabella. Is it eh? Is it eh? Eh? Or eh? Top left?
The second N.
Top right. So we have a positive A, so it's going up, but a negative B, so it's going left. So yes, it will look like eh. Okay.
What the heck
Now
is
let's
this?
move on to part B. Go ahead and do part B. I'll give you a few moments for that. All right, Anaya, what's the domain of that graph over there? Oh, okay. Good. So this is less than this is less than also. So or yeah, I don't know. But -infinity is less than x, which is less than or equal to 2. Is how you say it. But you're fine. I could tell you have the right thing. All right. Oh, can you give me the other one, please, Anaya? No. It starts at 0 and it goes up, right? There you go. All right. Now I want you guys to find the inverse. Do part C, go. I shall ask Dylan Smith. What did you get for your answer?
Answer of -x squared minus 2 equals 1.
Negative x squared what?
Minus 2 equals 1.
I think you're close. I think it's +2.
Yeah.
So he was close. So let me show you guys how to get that answer if you didn't get that. First of all, wasn't this the question? Oh, I've already switched the x and y, right? Okay, so we square both sides, right? Then we minus the 2. And then you divide by -1. Now, when you divide by -1, the x will change its sign, and so will the 2. So you had the right thing there, Tilly. It's just that after you do the division, go one extra step and do that. All right, so here's our next thing. I want you guys to now state the domain and range of the inverse. That shouldn't take too long. Go ahead. Good. And we're going to put equals for the ones that have numbers on them. So there you go. All right, now we get to do the fun part. We get to graph the inverse. Now, we said, what kind of a function is this?
Quadratic.
That's a quadratic. So you need to find your vertex. Then you decide, is it a happy face or a sad face? And then you're going to have to erase half of it. I'll say it again. Find your vertex, happy face or sad face, and then erase half of it. Because it can only be half. Oh, 2. Right. Seth Payne. Happy face or sad face?
Wait, when you get to 6, you don't
So my h isn't there, Rami, so that would be 0. My k is 2. It's a sad face because this number is a negative, right? So I'm going to draw a sad face parabola, which would look something like that. But now I need to ask Cain, which half should I erase so that it looks like the inverse? What do you think? It's kind of confusing because they're on top of each other. But let me help you. So I'll give you the visual help here. So if I erase the right half, it would look like this. Do those look like inverses of each other?
No.
That's option 1. Option 2 would be to erase the left half. Do those look like inverses of each other?
No.
None of them. They're just like either.
Neither one of them do, right? Well, one of them is. It's just because I didn't draw it very good. What do you think, King? Do I erase the right half or the left half? Yeah.
Ah, got it right.
So, I mean, you can kind of tell by the arrows, right? That kind of helps seeing those arrows there like that. So, oh, okay.
Yeah, when I did it my own paper, I was like,
What the fuck?
Okay,
student practice.
student practice.